right, so maybe you saw the course announcement that I posted yesterday. So this week we're going to review for test 4. And test 4 is everything's up there except for the actual test. The only reference sheet you're going to need is the periodic table. And I'll provide that as well. Oh, that's provided as a PDF. So I have the review sheet. We'll go over that today and Wednesday. And I'll use the Poll Everywhere software to hopefully make it a little more interactive. Someone is asking about availability. So test number 4 is going to become available on Sunday and then close on Tuesday. The final exam is going to actually open up probably Tuesday and close on Thursday. So there'll be some overlap. The final exam, I don't have a specific, excuse me, I don't have a specific review sheet for it because we've basically done all the review sheets. It's a cumulative exam, right? It covers all the tests, tests 1 through 4. So basically anything you've learned from those past tests. Now I thought about making test 4 earlier. So like, you know, coming out the end of this week, but I just figured you'd probably be better off with a little more time, unless you guys really want me to make it available earlier and close earlier. Oh, let me see. So the test 4 review folder, or the test 4 folder is here. The test will post here in this folder on Sunday. I think it's 8 a.m. Here's a link to the periodic table of elements. So let me click that. And this is the actual review sheet, the blank sheet. I'll post the solutions after Wednesday's class. So after we get through as much as we can, we might be able to make it through all of it. Depends on how quick you guys are answering the questions. Oh, some of you may have noticed the learning mod. I mentioned this before, but I'll mention it again. Module 9 and Module 10, the atom and the periodic table. I left those homeworks and quizzes open. In other words, if you still haven't finished them and they're late, you can still do them. So Module 9 and Module 10, you can still do. Don't forget about the extra credit. So again, both the homeworks and the quizzes, you should be able to go in here and like if it was past the due date, yeah, so I can still go in and start this. So Module 9, Module 10, you can go in and make it up if you haven't done it yet. And I figure it's the end of the semester, you might as well go ahead and do that. So you have some time in between now and the test to do that. Don't forget the extra credit. A bunch of people have submitted them. I'm waiting until probably the end of this week to start going through and closing them out. Yeah, so that's all I have. So there are specific questions. Jack, did that answer your question about the test?
Yeah, I think so.
Yeah, so the course announcements, I typically set them so they send out an email as well. But if for some reason you're not getting an email or you just want to check them, remember, go to course announcements. I mean, it's kind of late in the course to tell you guys about that, but all right. Let's see. So test 4 covers basically all of chapter 8, right? Atom and periodic table. And I basically just relisted the concept questions and parallel exercises from both of the module handouts, and all the key terms are here. Now, be able to find information on the periodic table. This is important. Let's see. Oh, I did post that supplemental video. I don't know if any of you watched it. Let me go there. So there's one in here. Oh, there's 2, I forgot. Yeah. So Rutherford the experiment and the model and of the atom. And then this is a neat one showing how regular ice floats and heavy water sinks in regular water. And then you have module 10. Let's see, did I put it in here? Yeah. Reaction of alkali metals with water. This is about a 6-minute video. It's a guy doing a demonstration, a chemist doing a demonstration in front of a lecture hall. And he's got a bunch of different apparatuses in the front where he can safely react alkali metals with water. So you can see them react with each other. All right, let's go through some of these. I put together a bunch of polls. Most of the questions I put in polls, so I had some time yesterday. Let me see here. How do I get to full screen here? Why is this not? There it goes. All right, so what I did is I activated this. Let me just put this full screen. So Rutherford, oh, yeah, here it is, up here at the top. Remember, poll everywhere, you just text the number 22333, and in the message you type D. Sarajanis 556. It'll let you join the poll, and then you can answer A, B, C, or D. So I'll give you guys like a minute or so to figure out this first to log in. In fact, I'll do it on my phone to see how long it takes. Or you can go to the website up here, pollev.com, and then D. Sarajanis 556. And whatever active question I have should show up. All right, let's see my text here. Five, 6. All right, so I joined the session. It took about that long for me to do that. One of these answers is definitely not the answer. Well, 3 of them aren't, but one should be obvious. Oops. This timer doesn't work. Oh, see, I figured out something. Oops, sorry about that. I clicked the wrong button. That's weird. All right, I'm gonna go ahead and do the responses on this one. All right, so we got empty space, electrons, and protons. Fortunately, no one guessed plum pudding, so that's good. Yeah, empty space was what Rutherford determined, and that was from his experiment with the gold foil and shooting particles, atomic particles at it, and seeing some of them bounce back, but most of them passing through. All right, the next question. What's the main difference between the atoms of different elements? So I gotta type in a time on each one of these. This should be a relatively straightforward one. I think I'm going to use 1.5 minutes for the timers. This is going to be a really boring video to watch. So remember, once you're into the text, you don't have to rejoin every time. So once you're in it, it's good for the whole class period. I'm not sure how long you need to be in it to get booted, or how long it has to be inactive to get booted. I know I've used it from day to day, and then just now I haven't used it in about a week, and I had to reconnect. All right, what does it happens at the end of the timer? Oh, it stops, freezes everything. All right, number of protons. Yes, number of protons. That's the correct answer. So that's the difference. That's the primary difference between number of atoms. Now, number of neutrons can vary, even within a single element. And then the electric charge is, well, most atoms are neutral, right? And the electric charge is just going to be depending on what valence electron it loses or gains. So this is the number of protons. Turn this light on. All right, so next question is, which two particles make up the nucleus? So I'm going to put 1.30 minutes in here. If I can get this thing to, what's going on? My number lock is on. What the heck? All right, 1.5 minutes on the timer. A lot of people answer. I'll stop early. We got 25 people 24 people in class today, so I expect big results here. This is very nerve-wracking waiting for the answers. Be careful, some of these are trick questions, or trick answers. I did have some fun making up some of the answers last night. Only 10 people participating. What is going on out there? Rest of you guys sleeping? You don't have cell phones? It's completely anonymous to text, and Poll Everywhere, as far as I know, does not record any of your cell phone information. In fact, we used to use this, my former company used to, well, the company I used to work at used to use Poll Everywhere for quarterly updates. All right, so let's see what proton and neutron. Yes, these two particles make up the nucleus, proton and neutron. Where's my, there it is, proton and neutron. I forgot to label which one of these questions I didn't make polls for. Let me, oh, okay, so this, ignore this one for now. Let me escape out of here. That's the next one. Okay. What type of electric charge do each of these particles have? I'll just go over these unless you really want to shout out the answer. So proton, does anyone want to answer this? Or I'll just write them out. So proton has a positive charge. All right, so remember the protons are in the nucleus, they have a positive charge. The electrons are in orbitals or spaces around the nucleus, and they have a negative charge. So this is important that you remember for a neutral atom, right? The number of protons and electrons are the same. So the number of protons you can get off the atomic number, and as long as it's a neutral atom, you can say, okay, the number of electrons equals the number of protons. And the neutrons are, there's no charge or neutral. Neutral. I guess you could write that as a 0, right? All right, let's go back to the poll here. Okay, which two particles in the atom have about the same mass? I'll just put in minute 30 there, start the timer. See if we can get, I think last time we got 10 or 11, let's get like 15 people answering. Come on, there's 24 of you. What are you guys doing? You doing other homework? You're not supposed to be doing other homework in my class. Show me your desks.
I don't know where. Also, what the heck is quark?
Oh, a quark is a subatomic particle.
Let me see.
Oops. All right, so what's the answer here? Oh, let me show the responses. Proton and neutron, yes. Remember, the proton and neutron make up the nucleus, and they have approximately the same mass. Thus, when we talk about isotopes, we talk about neutrons and, well, number of neutrons varying. So the neutron and the proton. The electron is tiny in terms of mass. It's got like, it's like less than 1,000th the mass of a neutron or a proton. So the neutrons and protons are on the same order of mass. In fact, they're the same to about, I believe it was 2 significant figures. Is what I reported. Let's see, what's the next one here? Oh yeah, mass number. Let me just go back to the sheet here. Yeah, so neutron and proton, same mass, approximately. All right. Define the mass number. So read each of these carefully and select the one that you believe is the correct response. Define the mass number. Eight results, come on. I'm trying to make it fun for you guys. It's like Jeopardy, or it's a quiz bowl. All right, let's see what the responses were. Okay, so most of you guessed the sum of the protons and neutrons in the nucleus. Let's see, number of protons. So number of protons in the nucleus is not the mass. Let's go through this. Yeah, so sum of the protons and neutrons. Remember, the protons and neutrons have approximately the same mass. The mass number is something you'd report for an isotope. Electrons are too tiny. Well, electrons are not counted. So mass number is typically used in the concept of isotopes, right? We say an isotope has well, we give the mass number and we can tell how many neutrons an isotope has. So let me write this down here. So define mass number. It's the sum of protons, and neutrons in the nucleus. And that's
in my notes, it says the atom. Is that the same thing?
the atom.
Yeah,
Oh,
for mass number.
yeah, I mean, okay. Protons and neutrons only occur in the nucleus. So yes, it's the same as in the atom.
Okay.
The atom has both a nucleus and electrons right around it. So it's the nucleus of the atom. So yes, it's the same thing. Just by definition of the nucleus contains protons and neutrons. And the nucleus is contained within the atom. So yes, the mass number of an atom is the sum of the protons and neutrons in the atom, which just so happen to always be in the nucleus. All right. Let's see, did I put the next one up as a... All right. Who's credited with discovering the nucleus? I'll put like 1 minute on the clock here. It should be fairly straightforward. One of these things is not like the other, as usual. I was going to put a serious answer there, but I thought, throw in an extra. All right, time is up. See the responses. All right, so let's see. Ernest Rutherford is the actual one credited with discovering the nucleus, and that comes from his experiments with the gold foil experiments, where he realized that the atom was mostly empty space. J.J. Thomson was actually his advisor. He's the one that came up with the plum pudding model, and he didn't really like that model, but he had a bunch of graduate students, and Rutherford was one of them. And Rutherford went off to discover this. Niels Bohr came up with the Bohr model of the atom, and that was later on. So he had already known about the nucleus. So let's write this down. So this is Ernest Rutherford. All right. Let's go to the next one here. Oh, I skipped that one. Oh, I must have. Yeah, I didn't like the choices I was getting for. I'll just write this one out. Okay. What is an orbital? So an orbital is, it's not just a fixed location in space. An orbital is the space, and this is in the current model of the atom, so the quantum model of the atom. The space around the nucleus in which an electron is likely to be found. So after the plum pudding model, Bohr came up with an idea that in order to explain the transition, why atoms give off light, he said, okay, electrons are in fixed orbits around the nucleus, and they jump from orbit to orbit. Now, the quantum model was developed after that in the 40s, and that's the current model of the atom. The quantum model describes orbitals because the quantum model realized that you can't know definitively where an electron is in an atom because of its dual nature of particle and wave. So statistically, they say there's a certain region around the nucleus in which an electron is likely to be found. And orbitals can have different shapes depending on the energy level and the electron that's associated with it. But an orbital is basically a space around the nucleus in which you're likely to find an electron. All right, so the next few we're going to need some, periodic table. Oh, you know what? I have it open. Let me zoom in and grab a screenshot of copper. And I will put it on. What is the atomic number of copper? Let me pull up the screenshot. So if you don't have a periodic table in front of you, here's copper. What's the atomic number of copper? So go ahead. Oh, I should put a. Oh, I forgot to. Sorry, guys. I put a minute on the timer here. And then re-display my copper. Atomic number of copper. So if you have the periodic table in front of you, you can look at the key. If not, you have to just kind of remember. All right, atomic number of copper. See the responses. All right, so the atomic number on the periodic table is, if I can find my, oh, I got it. Oh, yeah, 29 is the correct response. Let me show you why. I have no idea what that means. All right. So if you scroll out here on the periodic table, the atomic number is the top number. The atomic weight is the bottom number. Atomic number is always a whole number because remember, the atomic number tells you the number of protons for that atom, right? You can't have like a half a proton. The atomic mass. Oh, wait, did I? Which question did I ask here? Oh, atomic number. Oh, okay. Yeah, the atomic weight of copper is a statistical average of all the different isotopes, naturally occurring isotopes of the element out there. So the atomic number is 29. The atomic weight is 63.55. I'm just going to lump these two together because, yeah, so apparently I did have the other one up here. I didn't. Oh, we did that. Wait a minute. Did I flip? Did I change questions on you guys? No. Doesn't look like I did. All right. So let's write this down. I'm just going to do atomic weight and atomic number. So maybe that confused people because I jumped ahead. Atomic weight of copper is 63.55 AMUs. This is atomic mass units. So that's the atomic weight. Right, 63.55. And then the atomic number is 29. And that's 29 here. And just a reminder, this is the number of protons. All right, let's go to the next one here. All right, which component of an atom is involved in a chemical reaction? So you have 4 choices here. Oops, let me clear it. I don't want you to see the responses of the other people. So nucleus, electron, proton, and neutron. I want you to be biased by other answers. Oh, I forgot the timer again. A lot of you are not playing this game. It's very disappointing. What could be better than test review? All right, some nucleus, some protons. Electrons is the correct answer. Electrons are the ones that are involved in a chemical reaction. They're the ones, particularly it's the valence electron. So let's write this down. It's the electron. In particular, the valence electrons. The next one I didn't put a poll together for. What does AMU stand for? That stands for atomic mass unit. So remember, 1 proton is 1 atomic mass unit. 1 neutron is also 1 atomic mass unit. So atomic mass units correspond to the number or correspond to the mass of a proton or a neutron. All right. Let's see here. Should I do this as a poll? I think I can. Let me get a screenshot of carbon. All right, so remember, carbon, atomic number 6, atomic weight is 12. Let me get a screenshot of this. And I'm going to go in here, activate this, put the timer. All right, so how many protons are in a carbon atom? So I have the screenshot of carbon on the periodic table. How many protons are in a carbon atom? Go ahead and respond to that. Flip the page. All right. Let's see what the responses were. Yes, 6. 6 is the correct answer. So that's good. You guys know how to read off of the, well, at least 8 of you know how to read off of the periodic table. Atomic number corresponds to number of protons. Let's write this down. Protons in a carbon atom, 6. Atomic number. Let's see, did I make a poll for this one? Yes, I did. Okay, magnesium. You know what? Let me just get a screenshot of this. So you can see the I zoom in. I can. Hey, whoa. All right. No, don't. Uh-oh. All right, that's what I want. Full screen. All right. What do you mean save changes? Whatever. This is active. Let me pull up the magnesium isotope. How many neutrons does this isotope of magnesium have? Magnesium 25. So that's how it's written. 25 and the 12 and then magnesium. How many neutrons does this isotope have? Oh, I forgot to set a timer. That's all right. Give you another 30 seconds. All right, let's go over this one. Let's see, 13. It's the correct answer. So some of you put 12, some 37. Let's go through this. How many, oh, there it is. How many neutrons? So I wrote this down. The equation is mass number is equal to neutrons plus protons. Now, the way magnesium is written here, right, and the way I wrote it up in, well, I wrote magnesium, remember I also wrote it as magnesium 25. The atomic number, the number of protons is implied here by knowing the element magnesium. Magnesium has the 12 protons. So if you go to the periodic table, right, magnesium, oops. Has atomic number of 12. And this particular mass number is given as 25 right here. So the number of neutrons is just the mass number 25 minus 12, and that gives you 13. So that's where the 13 comes from. You can't have more neutrons. Like 25 is the total number of neutrons and protons. That's the mass number. And then the number of protons is the atomic number 12. And so the mass number is just the sum of those. Number 15, we already did that with number 13, so you guys are experts. So I'll just show you iridium on the periodic table. Here's iridium, IR, and number of protons is again the atomic number. So iridium has 77 protons. Let's just write that down. And number 16, I essentially already did for you up here. Represent the isotope magnesium 2512 in the alternative notation. So again, the alternative notation is just writing the name of the element with a dash and its mass number. And the reason we can do that again is because with the periodic table, we can just look up the element and find its number of protons. So that 12 is something we can find in the periodic table. Let's do one more of these polls real quick. So in terms of how they form ions, what's the major difference between transition and representative elements? So take a minute to fill that one out, and then I'll write it down. All right.
The poll is locked. Oh,
Yeah, I know the time ran out. Maybe 1 minute wasn't enough. Can I reset? Oh, yeah. Well, we're almost out of time here. So, okay, let's just show the responses. Let's see. Representative elements A tend to form one ion. Transition elements tend to form more than one kind of ion. Yes, this is correct. Let's look at the table here. Oh, I'll show you the correct answer. Got to exit. Now, one of the choices was representative elements tend to form positive, transition tend to form negative, or negative and positive. Now, the representative elements are all the A groups, right? And they can form positive or negative ions, depending on the side of the table they're on. But they tend to form just one type of ion. The transition elements are the ones that they're all metals. They do tend to form all positive ions. However, well, they actually do form all positive ions. However, they also tend to form more than one kind of ion. So you might get a +2 or a +3. So I wrote that down over here. Remember, the representative elements are all the A groups, and they tend to form one ion. And the transition elements B tend to form more than one kind of ion. All right, so we're going to just continue going through review on Wednesday. Half of you didn't even, well, I only got half the responses that, we had 24 people in the class. I was getting maybe 10 or less responses. So come prepared on Wednesday to answer questions, either texting them in or using the poll online. Print out, I would have a copy of your periodic table so you can look at it and figure some of these answers out when we get to them. So that's what I have today. Are there any questions before you go? Or? All right, so I'll see you guys on